This is a walkthrough of another GCSE Foundation practice paper. This is from Set 4, Paper 2F. I'm going to put timecodes for each question underneath this, and at the end of the video I'm going to scroll through the whole paper. So if you're just looking at this to check whether your answer's all right, skip to the end of the video and look at the scroll through of the answers. So this is a calculator paper. First question, simplify 3 times A times 5 times B. So we multiply the numbers together. 3 times 5 is 15. And A times B is written AB. So answer here is just 15AB. Question 2. Here is a hexagon. The angles of the hexagon add up to 720 degrees. Work out the size of the angle marked X. So we've got all of the other angles marked. So first thing I'm going to do is add all of the others together. And do that on my calculator, and I get 578 degrees. Definitely worth writing that number down as a result of your calculations. So the missing angle is going to be 720 minus 578. Again, you can do that on your calculator to save time. And that gives you 142. So the answer to this question, check, does it make sense? Is it an obtuse angle? 142 is obtuse, as in it's less than 180, but it's more than 90. So that makes sense for what X looks like. And I would probably do that on my calculator twice just to make sure in an exam. 142 degrees is the answer there. Question 3. The table shows the names of 5 of Jeanette's friends. Jeanette is going to play a team game. She chooses one of the boys and one of the girls to be in her team. Write down all the possible combinations Janet can choose. So we need to be strategic about this, have a strategy to follow. You'll notice that, and normally in questions like this, the first names always have a different first letter, or it's the same with menus as well. That means that you don't have to keep on writing out the full word. I can write DA to mean Dodie and Anna, or DM to mean Dodie and Michelle. So that's Dodie and each of the girls. Then we choose James, each of the girls, JM, JA, JM, then William, and both of the girls. And that's all the 6 possible combinations that Jeanette can choose. Question 4. What percentage of this shape is shaded? Well, let's work it out as a fraction first of all. 2 lines of 5, that is 10 squares in total, and 1, 2, 3, 4 of them are shaded. 4 out of 10 squares is 40 out of 100, 40%. Write your answer to part 1 as a decimal. 4 out of 10 is the same as 0.4, 4 in the 10th column. Question 5. Here are some words that can be used to describe the probability that an event will happen. Certain, impossible, likely, unlikely, evens. Write down the word that best describes the probability that you will win a raffle when 400 tickets are sold and you have 10 of the tickets. So it's possible that you'll win, but it's unlikely because your probability of winning is only 10 out of 400, which is less than evens. It would take 200 out of 400 to be evens. So 10 out of 400 makes it unlikely, but still possible. Write down the word that best describes the probability that you get a 10 when you roll an ordinary dice. That's impossible because an ordinary dice only has 1 to 6 on it, so getting a 10 is impossible. This is one of the rare questions where probability answers are words. Most probability questions in an exam will be asking for a fraction answer, but in this case, because they've asked specifically for the words, then you need to give a word. Continuation of question 5. Aisha is making a fair 8-sided spinner. The spinner already has the colors red, white, and blue written on it. The probability that the spinner lands on red will be 1/2, and the probability that the spinner lands on blue will be less than the probability that the spinner lands on white. So blue less likely than white. Complete the spinner by writing on it the colors that are missing. Well, first of all, we've got to make sure the probability of red is 1/2. That means that 4 out of the 8 need to be red. 4/8 is the same as 1/2. And then we have to finish off, and we have to make sure that blue is less likely than white. So as soon as I add a white, I've now made that second statement true. And I can continue here either by adding another white or a totally different color. So white is fine, but we're not told that other colors aren't allowed, so you could also put green or yellow or anything else, any other color in there. The only color you can't write in there, or colors that you can't write blue, otherwise probability of white would be the same as blue, and that's not allowed according to that statement. And you can't write red, otherwise your probability of red will be more than 1/2. So in this, white or any other color. So as long as you have 2 whites, at least 2 whites, only 1 blue, and 4 reds in total, then you're fine with that one. Question 6. There are 400 counters in a bag. 36% of the counters are yellow, 2/5 of the counters are blue, and the rest are green. Work out how many counters are green. So 36% of 400. On a calculator, you want to do that as 36 divided by 100, that's 36%, times by 400. And notice how of is the same as times. 36% is 36 over 100. So we are literally doing 36 divided by 100 times by 400, and that gives you 144 on a calculator, 144 yellow counters. 2/5 of the counters are blue, so 2/5 of is the same as 2/5 times 400. On a calculator, that is 2 divided by 5 times by 400. Or, other way around, 400 divided by 5 times by 2. Either way, it gives you 160 blue. Add those two numbers together. That gives you 304 that are yellow or blue. And the rest of them are green, so 400 minus 304 is 96. And so your answer is 96 are green. I'll put that on the answer line down here. Just check that it all adds up to the right number at the end, that it all adds up back up to 400 before moving on. Right, the length of a bus is 10 meters. Gurjeet makes a model of the bus. He uses a scale of 1 centimeter to 40 centimeters. Work out the length of the model of the bus. Give your answer in centimeters. So with a scale, usually the easiest way to work through a scale question is using a ratio. So our model to real life ratio is 1 to 40. 10 meters is the same as times by 100 to turn it into centimeters is 1,000 centimeters. And so I want to use this ratio to go from 40 to 1,000. And if I'm using the ratio, I would want to know what did I multiply by there to move from 40 to 1,000. In order to find that number, I do 1,000 divided by 40. And 1,000 divided by 40 is 25. That tells me that I've multiplied by 25 in this ratio. Do the same to the other side of the ratio, because always you need to do the same thing to both sides of the ratio. That means the scale of the model, 25 to 1,000, that means that the 1,000 centimeters of the bus is represented by 25 centimeters of the model. So the answer is 25 there. Question 8. Hussein runs a race. The graph shows his speed in meters per second during the first 10 seconds of the race. So we've got 10 seconds on this axis, first 10 seconds. You can see he's starting from nothing, getting very fast very quickly, and staying at a high speed most of the race, peak speed there, and then slowing down. Write down Hussein's speed at 2 seconds. So 2 seconds is that thick line there, and that reads across on the graph here. In an exam, you probably want to mark in that you're reading it off, so you draw a straight line up there, and then where it meets the graph, you draw a straight line across. Just check, is this halfway between 8 and 10? 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5. So that tells us that each square is representing 0.2 seconds, and that is 9 seconds in there. So the answer to his speed at 2 seconds is 9 meters per second. Write down Hussein's greatest speed. So we go to the highest speed in the graph. That's that one there. And read that off the graph. So again, draw a line to read where that is. That is just one square below 12, and each square is 0.2. Worth marking in that, 11. So 0.2, 0.4, 0.6, 0.8, 11.8 meters per second. And write down the time at which Hussein's speed was 7 meters per second. 7 is in here. So again, read off from 7. That hits the graph there. And now we have to really carefully read the scale here. It turns out it's the same scale. Every little square represents 0.2 seconds. So that's 1, 1.2, 1.4 seconds. And just check 1.6, 1.8, 2. Yes, that's the scale. So that's 1.4 in there. Therefore, 7 meters per second was reached at 1.4 seconds. Question 9. Michael writes down 4 different factors of 60. He adds the four factors together. He gets a number greater than 20 but less than 35. What 4 factors could Michael have written down? Well, just to make sure of this, I'm going to... This question has lots of possible answers. So I'm just going to write down all of the factors of 60. There are loads of them. 1, 2, 3, 4, 5, 6, 10, 12, 15. These are coming in pairs. 6 times 10 is 60, 5 times 12 is 60, 4 times 15 is 60, 3 times 20 is 60, 2 times 30 is 60, and 1 times 60 is 60. And then we're going to choose any 4 of these that add together to make a number more than 20 but less than 35. So if I choose 15, which is close to 20, and some small ones, 15, 16, 17, 18, 19, 20, 21, that works, but then you could also have perhaps 12 plus 6 plus 2 plus 1. Would that work? Yep. There are lots of different combinations. You've just got to make sure that they add up to more than 20, less than 35. So the one I've chosen are those 4 factors, but there are lots of possible answers for that one. Question 10, this is one where there's a complicated diagram, and as always with complicated diagrams, there's a lot of description that just confirms what you can see for yourself in the diagram. It's worth reading these to make sure that you have fully understood all of the implications of the drawing. So ABCD is a quadrilateral. ABCD is this here. What kind of looks like a kite but isn't a kite, I don't think, because I don't think that's the same length as that. DCS and PBC are straight lines, so DCS is this line, it's straight, and PBC, that line is also straight. BAD is 90 degrees, we can see from there. ADC is that angle at 68, PAB is 40, and PCS is 75 degrees. So everything as it looks on the diagram. Work out the size of the angle marked X, give reasons for your answer. So giving reasons is going to take some extra time. This is worth 4 marks, but there's quite a lot of working to do. So first of all, let's just try and find any missing angles. We know we're trying to get X. X is in a triangle. If I can find out what that angle is, then these 3 angles will add to 180, and I can find X. But I don't have this angle yet, and I don't have an immediate way of getting it. If I could add that angle to this angle, they would make 180. I can't get this angle yet because in order to get that angle, I need all 4 angles. Well, I need 3 other angles in a quadrilateral, and I only have 2 at the moment. So if I can find this one, then that will give me 3 angles, will allow me to get that one, which will allow me to get that one, and then finally to get X. So this is my strategy. First of all, 180 minus 75 is 105 degrees. Mark that in there. The rule that I've used there is that angles, or the reason I'm giving, angles on a straight line add to 180 degrees. Then I can get this angle in here by doing 90 plus 68 plus 105 is 263, and 360 minus 263 is 97. So I put 97 degrees in there, and my reasoning here is that angles in a quadrilateral add to 360. Then I can find this one again by doing 180 minus 97. So 180 minus 97 is 83. And again, I can put angles on a straight line. 180. And then find this finally by doing 83 plus 40 is 123. 180 minus 123 equals 57. And the reason for that one is angles in a triangle add to 180. And so that's finally got me my answer for x, 57 degrees. Lots of calculations on the way, and more importantly, the reasons given for each one. You need to make sure you give the reasons in order to get full marks for this question. So that is 57 degrees. Just make that final answer clear. X equals 57. There are so many numbers on the page, it's important to make the final answer clear. Question 11. Mr. Smith kept a record of the number of absences for each student in his class for one term. Here are his results. Write down the mode. So the mode is the most frequent number, the most common number, and we can see that there are 3 zeros and there aren't 3 of anything else. So the mode is 0 absences. You don't need to write absences, but it's quite useful when you're working out averages to write what you're actually measuring to remind you of what's sensible and what's not. Work out the mean. We need to add them all together. So you're going to do this on your calculator. The key bit of working that you need to show is that you have successfully added them together. So mean is, adding them together is 28, divided by the number that there are, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this bit is really, really important to show because this is worth 2 marks. And if you make some silly mistake with the number of counting it, so you count 9 instead of 10, for example, or if you just made some silly mistake in adding on your calculator, if you've shown this step, then you'll at least get a mark for the method. Whereas if you just write down your answer and it's wrong, you'll get nothing. So 28 over 10 is 2.8 absences as a mean. Question 12. You can use this rule to work out the total cost in pounds of hiring a pressure washer. Multiply the number of days by 5.4 and then add 15. Ali hires a pressure washer. The total cost is £52.80. Work out how many days Ali hires the pressure washer for. So for this one, you're probably just going to work backwards. £52.80 minus the 15 is £37.80. You can use your calculator for that if you need to. Good idea too, so you don't make silly mistakes. And now we do 3780 divided by 5.4 because we multiplied the number of days by 5.4 to get this. Divide by 5.4 and that gives us 7 exactly. So he hired the pressure washer for 7 days. Ben hires a pressure washer for Y days. The total cost is C pounds. Write down a formula for C in terms of Y. Now this doesn't you're not trying to work out how many days or his total costs. We're not going to know that. We're just writing down a formula that connects them. And remember, a formula has to involve more than one letter and an equal sign. And it's a relationship between 2 different letters or more than 2 different letters. In this case, the total cost is given by multiplying the days by 5.4. So 5.4 times by the number of days, and then adding an extra 15. And we write that more neatly as a formula by saying C equals 5.4y plus 15. Question 13. Mary works in a maternity unit. She weighs the babies. The table shows the weights in both pounds and kilograms. Use this table to draw a conversion graph to change between pounds and kilograms. So this means drawing the points that are necessary. We don't actually have to draw all of them, but it would be a good idea to, because you have time in an exam. So again, check the scale really carefully. We've got 4 there, 5 there. That means that it's 0.2 per little square. 4.2, 4.4, 4.6, 4.85. So 2, 4.4 is there. 3, 6.6. This is just going to take me a bit of time. I think I've gone wrong with that. Yes, I've got the pounds and the kilograms the wrong way around. So ignore that. 2 kilograms, 4.4 pounds. So 4.4 on this scale is 4.2, 4.4, 2 kilograms. That's a really common mistake to make, the one that I made. So just read really carefully what the axes are. 6.6 pounds is the same as 3 kilograms on that. 8.8 pounds, that's just one before 9. 8.8 is the same as 4 kilograms. And realistically, that's enough to go on now, because this is going to be a straight line graph. 11 and 5. 13.2 and 6. 15.4 and 7. And 0 pounds is going to be the same as 0 kilograms. So it does go through 0, 0, and this shows them in direct proportion. Change 10 pounds to kilograms. That means we're going to draw on a line, and I would definitely bother drawing on the line in the exam. 10 pounds is the same as, hits right in the middle there, that's 4.5 kilograms. Part C, change 6.6 kilograms to pounds. Is that 6.6? Nope, 6.5. I don't know why I read that. 6.5 kilograms to pounds. Again, we're drawing a line in the middle of that square. I've drawn it a little bit low. It comes down to there. It's in the middle of that square. 14.2, 14.3 pounds. Question 14. George is going to buy exactly 10 ink cartridges. One cartridge costs £9.39 per cartridge, but if you get them in packs of 3, they cost £24.30 for a pack of 3 cartridges. Find the difference in cost between the cheapest way and the most expensive way to buy the 10 ink cartridges. So, different ways to buy 10. We're buying, make sure you read it's exactly 10. So he's not going to end up with more than 10. He wants exactly 10. He can either do that by doing 3 lots of the expensive one. Sorry, not the expensive one. Three lots of the 3-pack and 1 of the 1 cartridge. So that's going to be 3 times 24.30 plus this £9.39. And that gives you £82.29 on your calculator. The other option is that he just buys 10 of the single packs. 10 times 9.39 is £93.90. And we asked for the difference in cost. So you'll get some marks for doing these calculations, but we need to find the difference between these two. So our next line of working is 93.90 minus 82.29, and that gives you 11.61. So the difference in cost is £11.61. Question 15. Henri and Ray buy some flowers for their mother. They buy 3 bunches of roses for $6.99, 1 bunch of roses and 2 bunches of tulips for $4.45. Work out the cost of 1 bunch of tulips. Now, this is an example of simultaneous equations, but luckily there's simultaneous equations that are so simple that we don't need to solve them in that way. We can just work backwards logically. So if 3 bunch of roses cost $6.99, 1 bunch of roses is $6.99 divided by 3 for 1 bunch of roses, and that gives you £2.33 for a bunch of roses. That means that this cost we can take and work backwards. $4.45 minus the 1 bunch of roses is £2.12. So 2 bunches of tulips cost £2.12. And therefore 1 bunch of tulips is, when you divide that by 2, which is £1.06. Henri and Ray share the total cost of £11.44 in the ratio of 5:3. Work out how much Henri pays and how much Ray pays. So this is basically a new question. In the ratio of 5:3 means how many parts in total. 5 plus 3 is 8. We need to take 11.44 and divide it by 8 to find out the cost of 1 share, or 1 part. So £1.43, 1 part. Henri has Henri has 5 parts, and Ray has 3 parts. So Henri spends £7.15 and Ray spends £4.29. And we check that by adding 7.15 to 4.29 to make sure that it adds up to the 11.44 that we had at the start. Always worth double checking those ratio questions, because you can make sure that you've got your answer right on the answer line. Question 16. Brian wants to go on holiday. He's going to take out a loan of £500 to help pay for the holiday. Brian will have to pay back the £500 plus 20% interest over 12 months. He will pay back the same amount of money each month. How much money will he need to pay back each month? So we need to know his total cost of the loan plus interest. So 10% of 500 is £50. And therefore 20% of 500 is double that, £100. So total for him to pay back is 500 plus 100, £600. He's got to pay that back over 12 months, so every month he is paying back £50. 600 divided by 12 is 50. So monthly cost, £50. Question 17. Calculate the length of AC. Give your answer to correct to 3 significant figures. Whenever you're told what accuracy, underline that accuracy to make sure that when you get to your final answer, you've followed that instruction. So this is a Pythagoras' theorem question. It involves a right-angled triangle. We can see the right angle there. No angles involved, so it's not trigonometry. It's just side lengths. And we know that the hypotenuse squared is the sum of these other sides squared. So we've got the hypotenuse. We therefore need to subtract the smaller side. So 18.6 squared minus 7.2 squared on your calculator. You don't need to write down this step, but you might want to, just to make sure you're doing the right thing and not making mistakes on the way. That's 345.96 minus 51.84, and that gives you an answer of 294.12. We need to square root that answer because we're using that formula a squared plus b squared equals c squared for Pythagoras' theorem. So we need to square root this answer here to find out what b squared was. 294.12 square rooted is 17.14992. And we're asked to give that to 3 significant figures. So we're looking at the first 3 digits and checking whether this third digit stays the same or goes up. It's followed by a 4, so it stays the same. 17.1 centimeters. It's always worth writing that on your diagram just to make sure that it's roughly believable. So 17.1 looks about right for that. This one's longer, and that should be. And they're all within, roughly 10 of each other, or 20 of each other. They're in the same kind of scale of numbers. If you'd written 294 down there, you would realize that you'd made some kind of mistake. So the answer is 17.1 centimeters, correct to 3 significant figures. Question 18. Chris has 2 children, Beth and Amy. Beth is 10 years older than Amy. Chris says, I am twice as old as the sum of Beth's age and Amy's age. And Chris is 40. How old is Amy? Now, you can just use logic on this, but it's going to get confusing. And definitely what they would expect, what the exam expects, and the easiest way to do it is to use algebra. So we think about the youngest person's age and give that age a letter. So Beth is 10 years older than Amy. We're going to call Amy's age X. And also, that's the thing that we're trying to solve for. But you always choose the smallest number and represent that with a letter. If Amy is X, then Beth is 10 years older, so Beth is X plus 10. We don't want to introduce a new letter for Beth. That would confuse things. We want to keep everything in terms of the same letter. Chris says he is twice as old as the sum of Beth's age and Amy's age. So let's do the sum of their ages is X plus 10. That's Amy plus Beth, which can be written as 2X plus 10. And Chris is twice as old as the sum. So that is double 2x plus 10. That's 2 lots of 2x plus 10. That is 4x plus 20. And that is equal to 40 years old, because Chris is 40 years old. So this allows us to write an equation. 4x plus 20 is 40, where x is Amy's age. And now we can just solve an equation. So minus 20 from both sides, that leaves you with 4x equals 20. Divide both sides by 4, and we get x equals 5. So Amy is 5, and just check that that works. Amy is 5, therefore Beth is 15. The sum of their ages is 20. Chris is 40. Yes, it all makes sense. So Amy is 5 years old. Question 19. A shop sells tins of beans in 3 different sizes. Kathy wants to buy exactly 750 grams of beans. Again, we have this exactly word. She can't buy more and end up with more than 750. She's got to find exactly 750. She wants to buy the beans at the cheapest possible cost. Work out the cheapest cost. You must show all your working. Now, in real-life situations, we generally find that when you buy things in bulk, you get them at a cheaper price, but we need to make sure that this is the case here. So let's find the cost per gram of each of these tins. Or maybe how many grams you get per pence. I think that's going to be easier in this case, but you could do it either way. So if she gets 150 grams for 35 pence, we're going to divide by 35 to get it by a single pence. So 150 over 35 is 4.3 grams per pence. 200 divided by 45, again per pence, gives you 4.4 grams per pence, so that one's cheaper. You get more per pence for this one than you do for that one. And this one we expect to be the cheapest. That is 300 divided by 80 for the pence, per pence. And that is, actually a lot smaller. 3.75 grams per pence. So actually, this is not good value for money at all. The best value for money is this, 4.4 grams of beans per pence. Slightly better than that one. And this one is actually a lot more expensive. You only get 3.75 grams per pence in this one. So cheapest possible cost, we want to use as many of these as possible because these are the cheapest. You get the most grams for your pence. So we're aiming for 750. We can do 3 times 200 will give me 600, and then add one of those gives us 750 in total. It's probably not a good way of writing that, just for... That's the total of 750 grams. So we need 3 lots of these beans and 1 lot of those beans. Work out the cheapest cost. So we've got 3 times 45p and 1 times 35p. And that ends up being 170p in total. So the total cost is £1.70. So just if there's no answer line, just make sure your final answer is given clearly at the bottom of all your working so that we can see where it is, so that the person who's marking it knows what you mean by your final answer. Question 20. Joe and Anne buy some fruit from the same shop. Joe buys 4 apples and 3 bananas for £2.50. Anne buys 3 apples and 4 bananas for £2.40. Work out the cost of 1 apple and 1 banana. Now this is proper simultaneous equations. We need to write out the 2 equations and adapt them so that we can get rid of or eliminate one of the variables. So if the cost of an apple is A and the cost of a banana is B, we've got 4 costs of the apple plus 3 costs of the banana equals £2.50, and 3 cost of apple plus 4 cost of banana is £2.40. In order to eliminate one of these, we need to have either the same number of A's or the same number of B's. I'm going to make it the same number of A's, so I'm going to find the lowest common multiple of 4 and 3, which is 12, and I'm going to adapt this first equation by multiplying it by 3, so that I get 12A plus 3 times 3 is 9B, and 3 times £2.50 is £7.50. And then I'm going to take the second equation and again get to 12A by multiplying by 4 this time. So that gives me 12A plus 16B. 4 times £2.40 is £9.60. And then I'm going to subtract one equation from the other in order to eliminate the A's. So 12A minus 12A is 0, which is why I've done it. 9B minus 16B is minus 7B. £7.50 minus £9.60 is minus £2.10. I'm now going to solve for B. So divide both sides by minus 7. And that gives me B equals 30p, £0.30. It probably would have been easier for me to do all of this without the decimals, just call it 250 pence, 240 pence, and work through in pence. But as it is, I've worked through in pounds, so I've ended up with banana is 30p. Having got the banana 30p, I now need to go back to one of my original equations. Let's choose this one and say 4 apples plus 3 times 30p is £2.50. That gives me 4 apples, minusing the 3 30p's, that's 90p. So 4 apples is £1.60. Divide both sides by 4 to get A on its own. And that gives me A equals £0.40, 40 pence. And then to be totally sure that I've done the right thing, I can try both of those costs with the second equation. 3 times 40p plus 4 times 30p is £2.40, which is exactly what it says there. So that tells me I'm correct, and I've got apple at 40p and banana at 30p. Question 21. In the question paper, this is actually printed as this E symbol, which represents the universal set, everything that we're talking about. A is even numbers, B is the set of multiples of 3. List the members of set B. That's everything that is a multiple of 3 here. We've got 3, 6, and 9. So those are the members of set B. Find A union B. That's both anything that's in A or in B or in both. Now, I think it's probably easiest for me to actually just draw a diagram and put these numbers in. So here's the Venn diagram that normally goes with this set notation. So A and B is the full set. E is the full set. And we've got these smaller sets, A and B. So even numbers, 2, 4, 6 is an even number and a multiple of 3, so it goes in there. Then I've got 2, 4, 6, 8, and 10 are the even numbers. B is multiples of 3, so I've got 3, 6, and 9. 6 is already in there. And the remaining numbers, we've got 1, 2, 3, 4, 5 hasn't been put in yet. 6, 7 hasn't been put in. 8, 9, 10, all there. So that's where all of the numbers sit in a Venn diagram. A union B represents everything in A or B or both. So those are the numbers 2, 3, 4, 6, 8, 9, and 10. Everything in both circles. A intersection B, that means A and B at the same time. That means this bit in the middle. So that's 6 only. And then it tells us that X, some number we haven't spoken about yet, is a member of the universal set. So it's one of these numbers, 1 to 10. This means is a member of B, so it's in B. And that means is not a member of, which means it's not in A. So we go back to our diagram, and it's a really good thing I've drawn the diagram now because it's going to be useful. I want something that is in B and not in A. In B is 6, 3, and 9, but 6 is also in A, so in A and not in B we're talking about this region here, and that's just the numbers 3 and 9. The possible values of X are therefore 3 and 9. Question 22. Neville saw this car for sale. He got a discount of 25% off the price of the car and he paid £7,200 for the car. As it says here, 25% off original price leads you to the price of $7,200. Work out the price of the car before the discount. This tells us it's a reverse percentages question. Two ways of thinking about this. Either you think about the percentage multiplier that would reduce 25%. So you've got your original cost X, and to reduce it by 25%, you would multiply by 0.75 because 100% minus 25% is 75%. So if we were working forwards, we'd do X times by 0.75, and that would lead us to the new price. So working backwards, the only time you divide with percentages, working backwards, 7,200 divided by 0.75 gives you 9,600. So that's the original price. The other way to think about it is that it's going to be the same numbers, but if we've got, as I said before, 100% minus 25% is 75%. So 75% is given by the 7,200. So we could write that as a ratio. 75% of the original cost is 7,200. Therefore, divide by 75. 1% of the original cost is £96. And therefore, if we're going up to 100% times by 100, that is 9,600. Either way you're doing it, that's going to lead you back to your original cost. Remember, the most important thing here is not to find 25% of 7,200 and add it to 7,200, because 25% of 7,200 is not the same as 25% of 9,600, which is the question we're actually dealing with. And the point of this is that you can't find 25% of anything originally because we don't know what the original value is yet. So we need to use one of these methods to work backwards and find the original price. 9,600. Final question, question 23. Keith, Ben and Liz tested a coin to find out if it was biased. So this is a coin that may or may not be biased. They each threw the coin a number of times. They counted the number of heads and the number of tails they each got. And this table gives the information about their results. So Keith got 12 heads, 28 tails. Ben got 34 heads, 66 tails. Liz got 57 heads and 243 tails. Which person, Keith, Ben, or Liz, will have the best estimate for the probability of getting a head on this coin? This is a slightly confusing question in that we can see that Liz gets proportionally. So Keith gets just over double the number of tails as he does heads, and Ben gets slightly less than double, and Liz gets way more than double. And if this was a fair coin, you'd feel like Liz was just really unlucky in getting, or lucky, getting more tails than heads. But the point is that this could be a bias coin, and whenever you're asked who has the best estimate, we're thinking about who did the best experiment. And the answer is Liz did the best experiment, even though the results are not what you'd expect for a fair coin. We're not necessarily talking about a fair coin. We're probably talking about a bias coin. And she's done the best experiment because she's done the test the most times. So the answer here is that Liz will have the best estimate. And technically what we call this is the most number of trials, because she did more trials, or she did the most trials, we'll say. Question B, using all the results in the table, work out an estimate for the probability that the next throw of the coin will be a head. So we're going to work out the relative frequency of heads compared to throws, and that will become our probability of getting a head with the next throw. So total number of heads, we've got 12 plus 34 plus 57, which is 103. Total number of tails, we've got 28 plus 66 plus 243, which is 337. That means number of throws is 440, 103 plus 337. And therefore, relative frequency of heads, you don't have to write this, but it's good at using the language. You don't have to write it at all. Relative frequency of heads is 103 out of 440, and therefore the probability of getting a head with the next throw is exactly the same number, 103 out of 440. If you do that on a calculator, you get something that's roughly 0.23, but this is more accurately written as a fraction, so that is a perfectly good answer, 103 out of 440. Okay, that's the end of that paper. So at this point, I'm just going to scroll through the whole thing again. And here are your answers. So just pause it if you just want to check. Question 1, 15 AB. Question 2, 142 degrees. Question 3, those 6 options. Question 4, 40% and 0.4. Question 5, unlikely, impossible. Question 6, 3 of them have to be red. At least one of them has to be white, and your final one can be white or any other color written in. Question 6 is 96 green. Question 7, 25 centimeters is the length of the model. Question 8, we've got these readings from the graph. You should have 9 meters per second, 11.8 meters per second, and 1.4 seconds. Question 9, loads of different possible answers here, but 4 that work, 15, 1, 2, and 3. You just have to make sure you've chosen 4 of those numbers that have a total of greater than 20 and less than 35. Question 10, you need the reasons. Angles on a straight line add to 180, angles on a quadrilateral add to 360. Angles on a straight line, 180. For each of these calculations, angles in a triangle add to 180, and altogether these lead you to your answer of 57 degrees for x. Question 11, mode is 0. The mean total divided by the number of values you've got, 28 over 10 is 2.8. Question 12, A, 7 days, B, C equals 5.4, Y plus 15. Question 13, your graph should look like that, a straight line that ends up going through 0. And your answers are 4.5 kilograms and 14.3 pounds. Question 14, difference in costs. You've got one 93.90, the second 82.29. The difference is £11.61. Question 15, tulips cost £1.06, and the costs that they each spent, Henri £7.15 and Ray £4.29. Question 16, he has a loan of ultimately £600 with the interest added, divided by 12 is £50 per month. Question 17, 17.1 centimetres to 3 significant figures. Question 18, use algebra to solve this. Amy is 5 years old. Question 19, this is the cheapest tin, or the best value for money tin. Therefore, you get 3 of those, and 1 of those, leaving you to a total of £1.70 for the 750 grams. 20 simultaneous equations, complicated if you haven't studied this already. The answer is 1 apple is 40p, 1 banana is 30p. Question 21, A, 369, B, all of these numbers, 2, 3, 4, 6, 8, 9, 10, C, 6, and X is either 3 or 9. It's a member of B, but not A. Question 22, reverse percentages, £9,600. And question 23, Liz has the best estimate because she did the most trials, and the probability of getting heads with the next throw is 103 out of 440. Hope you found that useful. I'll be doing one more of these. I expect to finish off set 4, but I won't be doing that immediately. I'll probably do that in January.